Fill in the missing reagent, reactant, or product in the following reactions. So here this is an SN1, SN2 type of reactions. So of course we have a substrate, we have a nucleophile, we're going to write the product. So just like in any SN1, SN2, you look for your leaving group, which is going to be the Cl minus. What kind is it? Primary, secondary, tertiary, and in this case, this is a primary halide, and you have a nice small nucleophile NH2 minus, so which means that this is possibly going to be an SN2 type of mechanism. And so if this is SN2, then all you have is a very straightforward attack of the NH2 minus and then the leaving of the chlorine. And so here we have our product written out, and then of course the chloride as the leaving group. Now in an exam or homework, if you forget to write the chloride, I'm okay with it, provided you know that this is going to be a leaving group. All right, so you can write minus Cl minus here also on the arrow, and I'm okay with that. Let's look at the next one. And in the next one, we are given the product. All right. And so we are supposed to figure out the reagent and the substrate ourselves. So when we look at the products, we know that here is the OH and here is a methyl group. So we have not learned how to make carbon-carbon bonds yet. So we can't attach a carbon. We can, however, attach an OH. Okay, so if you're attaching an OH, it means that this must be then the nucleophile. So I have to have hydroxide as a nucleophile because that's in my product. So now let's look at what our substrate is going to be. The methyl group that we have here, which is coming out of the plane, will stay out of the plane because nothing is happening to it. Okay. On the other hand, here the hydroxide is going behind the plane, so which means that we have to start thinking, okay, if the stereochemistry is given to me, it's obviously important, which means that this is more likely going to be an SN2 reaction rather than SN1, because in SN1 stereochemistry is not important. Or you can say that you get a racemic mixture, so you get an equal quantity of both S and R. So we are going to go ahead and take this as an SN2. If you have SN2 kind of a reaction, then of course you have inversion of stereochemistry. So if this is going behind, then my leaving group has to be coming out of the plane. What kind of a leaving group do I want? I just want a good one. Okay, it doesn't matter what it is, but I just need a leaving group to leave. Okay, and a good leaving group is either going to be a chloride or a bromide. So you also keep it simple. So two important things here that you had to take care of. You have to know the mechanism. Once you know the mechanism, then you know the stereochemistry also. Okay, and the OH here tells you that you should have a hydroxide as a nucleophile. Okay, let's look at the last one now. In the last one, we have also stereochemistry given to us from looking at it. So here is the reaction going on this carbon. The rest of the chain is just fine. And so here bromide is the leaving group, which means I can write this if I want to. I can also see that OET is attached, which means that I have to have ethoxide as my nucleophile, and essentially this is it. Okay, and then if you had to classify whether this is going to be an SN1 or SN2 reaction, you would say that this is going to be SN2 reaction because there is inversion of stereochemistry going on. So that's how you will approach these kind of problems.